So till this null graph was there in the previous video. Null graph has no nodes. So if there is no nodes, no edges, even if there are nodes, but there are no edges. Okay, so that's what we discussed in the last class. Now let us see few elaborative discussions on undirected and directed graph. So if you have an undirected graph, then degree and the way your edge is inclined on the vertices is important to be known here. Now here I have u to v vertex edge. There is edge L. Let's say we call it as E. Now what is this E? How do I call this E as? I call it as incident. What do I call it as? I call it as incident because it is incident on u as well as it is incident on v. So when a edge is incident on the two vertices, this edge becomes incident and this two vertices becomes adjacent vertices. Please remember this. This two becomes adjacent vertices because they are adjacent to each other. And how do they become adjacent? They become adjacent only because of the incident edge that falls on both u and v. Alright, so that is how we have to define the adjacent and incident. We must know this because later on we will have mathematical calculations based on this. Next point you must understand here is degree of vertex. Yes, you know what is degree of vertices, isn't it? You know what is degree of vertices. Now, in case of undirected graph, what is the degree? It's nothing but DEZ, degree of V. What is V? V is any vertex V. Let's say for example, in our case, degree of the degree of U in our case, this degree, I'm not able to write. Okay, let's say, okay, in our case, degree of V, matlab this degree. What is the degree of this? This degree of V is 1 because I have only one vertex on it. If I have this vertex, this edge also on it, then what does it becomes? It becomes 1, 2. Degree of V would have become 2. So the pendant vertex will always have a degree 1. Alright, pendant vertex will always have a degree 1 and isolated vertex will always have a degree 0 because this is isolated vertex which is not connected to anyone. Now I have a question. The number of edges incident on any vertex is a degree. Okay, degree of V vertex. But then how can we say that a loop contributes twice to a degree? Why? You need to write it on the copy. Why a loop contributes to twice the degree of a particular vertex. Alright. Now how do I represent? You must know this. How do I represent? I represent using V vertex. V has a how many? 1, 2 and 3 vertices. 1, 2 and 3 vertices. Right? Then I have an edge. What is the edge? U2 W is one edge. U2 V is another edge. Only 2 edges. Then what is degree of U? Degree of U is 2. Degree of V is 1. Degree of W is 1 and degree of k is 0. W and V are pendant and this k is isolated. Alright. Now the same thing if it goes to directed graph, no? The question becomes the concept becomes little changed here in terms of a directed graph, because in directed graph what do we have? We have a initial vertex as well as terminal vertex. In case of our directed graph, we have adjacent vertices. These are adjacent vertices. Yes, but we have incident U and V. This is incident on the U and V. But how? What is the degree? How it is incident? In the sense, we must know that we have an initial vertex and we have a terminal vertex. We have an initial vertex U, terminal vertex V. So this is incident on V. This is incident on W. Similarly, this is incident on W. Alright. So when we talk about degree in case of directed graph, no, we have two types of degree. One is in degree, another is out degree. In degree is represented using minus, out degree is represented using plus. Right? In degree means the number of edges for which U is a number of edges for which U is a terminal vertex. Alright. Alright. The number of edges for which U is a terminal vertex. The number of edges U is an initial vertex y1 j, then it becomes a, what does it becomes? It becomes a out degree. That means how much ever are going out, how much ever are coming in. So in kati jana sir? In I have, in W I have 1, 2 in. In V I have 1 in, 1 out. So that is how in and out degrees are maintained. So you can say this degree of minus is what? It's a in. Degree of plus is what? Out. Right? So out degree of U is 2 because duita out on the center A. So in degree of U is 0 because there is no in. So you must go through this also. Now I have few assignments here. You are supposed to draw a complete graph of 5 vertices. Complete graph. I don't know what is complete graph. Go back to the video and see. Now next is draw a directed, understand this, directed non-looped graph, non-looped, it doesn't have a loop, of 5 vertices, but then having only 6 edges. Non-looped but 6 edges. Alright, so do this part. Next is same thing for this figure 1. For this figure 1, this is figure 1. For this figure 1, find out the set of vertex V, set of edges E, right? Set of edges E, then in degree, out degree of each vertices. In degree, out degree of each vertices. Alright. And for the figure number 2, this is figure number 2, do the same exercise, right? Do the same exercise. Write down the set of vertices V, write down the set of edges E, and write down all the degree of all the vertices. Similarly for figure 3 also do the same thing. And this is your figure 4. Alright. do this part and we will see in the next class. Okay, bye.